Hey guys, and welcome back to Miss Carasolis's classroom. We are going over graphing linear inequalities today. So we've already discussed system of equations. So now we're moving on to inequalities. We will do system of inequalities also before our test, and then that's pretty much the whole test. Linear inequalities, system of equations, system of inequalities, okay? So here we go. So first thing we're going to start with is some steps. So always remember, convert your inequality to slope-intercept form. Make sure when you go to convert, if you divide or multiply by a negative, your sign has to flip, okay? So anytime you divide or multiply by a negative, your sign is gonna flip. Second, you're going to determine what kind of line you're going to use. So a boundary line, just like when we graphed inequalities on number lines, we used an open or closed circle. Now we're going to determine the boundary line. Third step is to graph. And then fourth step, you are going to determine which side to shade, because remember, inequalities, they represent infinite solutions, not just that one solution like a line would, okay? So just like on a number line, when we draw an arrow to show the direction, all the positives are a solution, all the negatives are a solution. Now we're going to actually shade in either the top of our graph to show all of those are a solution, or the bottom of our graph. So first thing we need to talk about is our inequality symbols. So when we had just the less than, greater than, we used an open circle. When we had the less than or equal to, greater than or equal to, we used a closed circle. So now for that open circle, we're going to use a solid line. Oh, and I did that backwards. A dashed line is actually for open circles. Solid line is for closed circles. So go ahead and switch those. Okay, example 1, negative 3x plus 5y is less than or equal to negative 25. So first we need to isolate for y and change this into slope-intercept form. So we're going to move that 3x over and divide by 5. So we'll add by 3x. We're left with 5y is less than or equal to 3x minus 25. Divide everything by 5. And then we have y is less than or equal to 3/5 x minus 5. So this is kind of the easy part. So here comes the little more tricky part. So we do have our m and b. M is 3/5, so that tells us go up 3 over 5. And b tells us where to start or begin, which is at negative 5 on the y-axis. So we're going to start at negative 5. We are going to go up 3. We're going to go up 3 and then over 5. And we are looking at that inequality symbol. Since it is a less than or equal to closed circle, we're actually going to draw a solid line. So go ahead and, okay, so we're actually going to use a solid line. So now what we need to determine is what side to shade. So there's a couple things that you could do for this. You could either use a test point, you could look at your y-intercept, whichever one's better for you. I'm going to show you both. So first thing, let's choose a test point. An excellent test point is always the origin 0, 0, because it's right in the middle. I know that it's either going to be a part of my solution set or not. It's just whatever gives me a true statement. So I plug in 0, 0 for x and y, and I solve. So 0 is less than or equal to negative 5. That's not true. So since we ended up with a false statement, we're going to shade everything that does not include 0, 0. So that would be anything below the line. Another way you could look at that, you can go ahead and plug in still, but it's still the same to look at your y-intercept and just look at y is less than or equal to negative 5. So because I'm saying y, so my y-axis, get to negative 5 is less than or equal to negative 5. That means anything's below. So that means the bottom of my line is shaded. And that's how we determine that. If we were to have ended up with a true statement for that 0, 0 test point, then we would have shaded anything above. Okay, so example 2, it says example 1, but that is example 2. So 3x minus 2y is less than 10. Let's go ahead and solve this. So subtract 3x to both sides. You're left with negative 2y is less than negative 3x plus 10. So because that negative 2 next to the y is negative, and I'm going to divide everything by that, let's go ahead and divide first. That means that I need to flip my sign. So now I am at y is greater than 3/2 x minus 5. So I have my m and my b. Good to go. I've got my graph. Now I need to determine the kind of line. Before I do that, let's go ahead and put some points. 1 at -5. And then we're going to go up 3 to the right 2. And because this is just a greater than sign, that means we're going to do a dashed or dotted line. So we have a dashed line now. So now we're going to determine what side to shade. So test point 0, 0. 0 is greater than -5. That is a true statement. So I'm going to shade anything above. So the whole top of that line is shaded, okay? Something that I want you to notice is because this is a dashed line, that means that anything that falls on that line is not included in the solution set. Anything that's in the shaded part is included. So now choose all the solutions of the following inequality. So y is less than 3/4 x minus 4. Let's get a graph. Let's get some answer choices. So we're choosing any of these that are solutions. So first thing I would need to do is graph. So -4 up 3 over 4. Dashed line, and I would be shading below. The reason I didn't leave that first point there is because it's actually one of my answer choices, and I like to graph all of my answer choices. So first we're gonna graph 1, 4. It's nowhere near my line or in the shaded area, so it is not a solution. Next one is 0, -4, and we just talked about this. Since it is on a dotted line, it is not a solution. Next, we are in the shaded area with 2, -3, so that is good to go. And last, we have 6, 0, which is also in the shaded area. So C and D are both answer choices. Now, if you wanted to do this without graphing, there is a way you could do that. You plug in the point into your inequality and just see which one gives you a true or false statement. So this first one, we would get 4 is less than -13.25, which is not true. Next one, -4 is less than -4, not true. -4 is equal to -4. Next, -3 is less than -2.5. This is true. -3 is smaller than -2.5. And last, 0 is less than 0.5. That is a true statement. So then we're good to go. And that's it. Bye guys. See you later.